All right, so here's example 2. Now, it says use the sum or difference identity for cosine to find the exact value of cosine 735 degrees. Now, with this, just like we kind of did before, like a couple of things go pretty early, couple of like units ago, I guess you could say, we talked about using reference angles and everything to be able to figure out what should actually be the value of this number or something that's bigger than 360. So here, the best thing to do, um, because this is more than 360, so we're not even in the first, second, and third quadrant the first time go around. It's actually rotating around multiple times. So here, our cosine of 735, if we can actually subtract 360 from it until we get down to something that's in the first quadrant, or if just even in the be, between 0 and 360, then that'd be great. So our first step is to get the degree of the angle between 0 and 360. But also, just in case if we have like radians here, we need to get between 0 radians and 2 pi radians. So we also need to get that way too. So and that's the ditto marks here. So get the angle between 0 and 2 pi radians also. So here, that's the first step to do here with 735. So if we do 735, we subtract 360 from that, what do we get? We get 375, right? Perfecto. All right, but 375 is still bigger than 360, so 375, and hopefully you can already look at it and tell me what the answer is without subtracting it. We get answer 15, right? Cool. So technically, we're looking for cosine of 15 degrees, which is the same thing as cosine of 735 degrees. Now, with this part, we don't really have an angle of 15 degrees that we have a value for that we can know off the bat. So what we're going to have to do is figure out, because it says using the sum or difference. Sorry. It says use the sum or difference identity for cosine, means that we're going to either have to find two values that either add to get 15 or two values that subtract to give us 15 of angles that we know values for. So if we look at our unit circle here, just the first quadrant of our unit circle, and that looks horrible. Sorry about that, guys. Looking at our quadrant here for first quadrant. So we have all of our angles going on. We have 30, 45, 60, and 90. And we're trying to see what can we subtract here that will give us a positive 15 degrees. And with this one, you can use multiple answers for it, because you can do 45, well, to give us 15, there's nothing you can really add together to give you 15. But what we can do is take two numbers and subtract them to get us the 15 that we need. So with this part, we would end up using our difference one, x minus y, because we can subtract two values over here to give us the value of 15. Because again, there's nothing that you can add together to give you 15 here that are positive angles from our quadrant right here, first quadrant. So here, I'm going to go ahead and put out the identity. And again, we're talking about our cosine, so the cosines are the same. The cosines are together, the sines are together, and the opposite signs in the middle. So subtraction and this addition. And again, hopefully everybody understands why we just did subtraction there. I really hope so. Please, if you don't, stop the video and ask me to come over to help you understand that again. Now, with this, it's up to you what values you use, that if you subtract the two will give you the value of 15. So you can say 60 minus 45, or you can say 45 minus 30, because they will both give you 15 degrees, right? Right. So it's up to you which one you want to use so that we can get the 15. I'm going to use the smaller ones, so 45 and 30, just because they're smaller. So it's up to you, and you will still get the same answer here. All right, so if we put that in there, we're going to keep this part here, and we're going to say x is 45 and y is 30, because again, when you subtract it needs to be cosine 15. I'm going to go ahead and put this here. So we subtract those two, it is 15. But that means here that for every x we see, we're going to put 45 degrees. Every y we see, we're going to put 30 degrees. So here, this is cosine 45 degrees, cosine 30 degrees, plus sine 45 degrees, times sine 30 degrees. And again, this is one of those things I was telling you before, that you have to make sure you remember the values of it, because they're going to expect you to know these without looking back at the unit circle and then trying to figure out what's going on and all that great stuff. You're supposed to know it. So here for cosine, this is square root of 2 over 2. Cosine of 30, cosine of 30. And again, if you know the graph of it, you know it comes from positive 1 up here and goes down. So 30 degrees is about right here, so that would be square root of 3 over 2. And again, if that doesn't make sense to you, that's fine. Just know your values from your unit circle. All right, so sine again is 45 is square root of 2 over 2. But this time sine of 30 degrees would be 1/2. So here we're expecting you to know these values, not actually have to fish them out and try to remember what's going on. You have to know them also. So not only do you have to know your identities, you have to know your values. All right, so here we're going to go ahead and multiply things together. So if we multiply this together, that'll be square root of 6 over 4. And this would be square root of 2 over 4. And if we combine those, you know, you can't just combine the square root of 6 and the square root of 2 by adding. The only way you can combine them is if you multiply, which you did here. They gave us 6. But here we're adding, so we have to keep them together. We can't simplify them or separate them or combine them, I mean. So that's square root of 6 plus square root of 2 all over 4. And no, simply because you have a 6 here, a 2 here, and a 4 here, you cannot simplify them down, because the numbers have to be in front of the radical in order to simplify. So that means here cosine of 15 degrees is actually square root of 6 plus square root of 2 over 4. So again, here with these problems, they expect you to know your trig values from the unit circle, but then they also expect you to know your identity. So it's important that you know them both and then go from there. Right?